To the Athenaeum of Philadelphia. I'm Beth Hessel, the Executive Director at the Athenaeum. We are one of a small collection of independent member-supported libraries that are still here in the United States. We are in Philadelphia, and the building that you are seeing behind me, this is our library. If you are visiting from Iceland or Canada or Indianapolis, please come to the Athenaeum. We are a circulating library and a special collection library that emphasizes architecture, Philadelphia's architecture and architects, and have a wide variety of programs from literature to history to the built environment, and lots of writers and researchers and everyday neighbors who come by and make this their library, their place to write, to read, to work, to find the latest great work, or fun beach read before they go on vacation. So we welcome you all, are glad you're here virtually with us today. This is a fun program we're all looking forward to. It grows out of the Athenaeum having some questions about some of the books that we had. And our library staff went and visited with Dr. Melissa Tadone at Winterthur Museum to find out if we had arsenic in our books, and thought that it was so fascinating. We invited her to come and speak with us. Dr. Melissa Tadone is lab head for library materials conservation at Winterthur Museum, Garden and Library, an affiliated associate professor in the Winterthur University of Delaware program in art conservation. I suspect we have a lot of people here today who are graduates of that program. She's a founding co-chair of the International Biotoxicology Working Group and holds a PhD in literary history from Yale and an MSIS-CAS in conservation of library and archival materials from the University of Texas at Austin. And I think, as we'll find, she's passionate about libraries, conservation, education, and advocacy, and health and safety and cultural heritage work. Melissa, it is so wonderful to have you here. I'm going to turn it over to Melissa, and at the end of her talk, I will moderate the Q&A. So anytime you have any questions, if you could put them in the Q&A, if chat is your only option, put them there, but it'll be a little easier with so many people on this program for me to follow them on the Q&A. Melissa, welcome. Invite everybody to join me in virtually welcoming Dr. Melissa Tadone.
Thank you so much for that introduction, Beth. Can everyone see my screen? Great. Well, thank you for being here today. I am speaking on behalf of myself and also my research partner, Dr. Rosie Grayburn, who is the lead scientist on the project. And in addition to our roles at Winterthur, Rosie and I are both faculty in the Winterthur University of Delaware program in art conservation. And so I'd like to share this living land acknowledgement, which was developed by UD faculty and staff in consultation with the Patuxet tribal leadership. All of the wonderful research that we are able to do at UD does benefit from this unfortunate history. And so it's important for us to acknowledge that and to try to move forward and do better. So it's conventional to put acknowledgements at the end of a talk, but I am actually putting my acknowledgements here because I would really like to make the point that a research project like this does not happen just because of one or two individuals. This research project really relies on an entire community, whether those people are our colleagues at Winterthur or the University of Delaware, external consultants, colleagues at other institutions who have very generously sort of taken up the banner and contributed data of their own, and funders as well who have supported this research. So I'm the one speaking today, but I am really the voice piece for many, many individuals and institutions who have contributed to this project. So what is the Poison Book Project? It began with the discovery of an arsenic-based pigment called emerald green on a 19th century binding in the Winterthur collection. The binding was being treated in a library lab for an upcoming exhibit. And, Bright green in cultural heritage materials has long been associated with arsenic, and so we just thought we'd test the book and just to be sure that I wasn't being exposed to arsenic during treatment. But it turns out that it was an arsenical binding, and that really raised a lot of questions for us. Suddenly we were wondering, well, how common is arsenic containing book cloth on 19th century books? Might we have other emerald green books in our collection? Might they be in the circulating collection? That was a big concern for us. And then we also wondered how much arsenic is present here. Is it just going to turn out to be a tiny trace amount, or is there a lot of arsenic in a single binding? And then we also started wondering about other brightly colored 19th century book cloths. Might there be other toxic elements present as well? And so that really sort of kicked off the Poison Book Project, which is, at least initially, it started as an investigation of Victorian-era book cloths. We were specifically looking at the brightly hued book cloths. And that's because we felt fairly confident that cloths that faded over time were probably colored with organic dyes. So we were really looking at the bright, brilliant hues and questioning what materials were present that were creating those colors, and should we be worried about them? So the goal of the project is, of course, on one level, just connoisseurship. We want to contribute to our knowledge of the history of the book. And then the other major goal of the project is to better inform health and safety practices for people who love, own, and work with these kinds of books. So as you can see here, these are 4 brightly hued examples of 19th century mass-produced publishers' bindings. The books at this time were slowly undergoing this transition from being bound by hand to being, they were still bound by hand, but with the help of machinery that allowed production to speed up. So we call them mass-produced, but it's not mass-produced in the modern sense of that term. It wasn't an entirely machine process yet. People were very much involved with sewing books by hand, covering books by hand. They were just doing it in very large binderies where the work was broken down into a sort of assembly line process. So up until the 19th century, you might see books covered in leather or parchment or paper, but book cloth, really commercially successful book cloth, was an invention of the early 19th century. You might see books bound in cloth from earlier periods, but they tended to be dressmaking fabrics like velvet or embroidered cloths, or even something like printed calicos. And they weren't durable as a bookbinding material. They did not hold up to the use that books undergo. So when this material was invented in the 19th century, it changed what the book buying public was really expecting from books as a retail product. And it allowed books, as you see here, to be quickly decorated and sold as a retail product. So as I mentioned before, we're really interested in the brilliant colors that don't really show much in the way of fading or color shifting. Those are the pigments we're concerned with. So Winterthur Library holds around 12,000 of these decorated cloth publishers' bindings. And they can be found in both our rare book collection and our circulating collection. So once we found that one arsenic-containing emerald green binding, we decided to do an analytical survey of the collection. We did a random sample, and we surveyed just over 200 books in a whole rainbow array of colors. And you can see 2 of our interns here, Layla and Sarah, and they are using a handheld X-ray fluorescence device. We call it XRF for short. And they are actually working in the stacks and scanning book cloth. And what the XRF can tell us is it produces a spectra that we can compare. A spectra is basically, it looks like a line graph with multiple lines and peaks. And we can compare that against the spectra of known materials. And that helps us identify what elements are present. It's really handy advice, but what it tells us is basically yes or no, is a certain element present? And then in the cases where we did find a toxic element, such as lead, chromium, mercury, arsenic, we were able to follow that up with a different kind of analysis called Raman spectroscopy. And what Raman tells us is the molecular structure of the compound. So in the case of emerald green, the XRF told us arsenic and copper were present, and Raman told us that the molecular compound was copper acetoarsenite. So I'd like to point out that this sort of analysis, it's not like on television shows like CSI or NCIS that you might see where they take a sample and they plug it into a machine and then the machine like spits out an answer of what the material is. This sort of analytical work is a little more, there's a little more work on the back end. You have to sort of know what you're looking for so that you can compare your results against known results. So what are some of the toxic pigments that we found? We found a lot of chrome yellow. The compound is lead chromate, and it contains both chromium and lead, both of which are toxic elements. And you can see here some examples of chrome yellow bindings in the Winterthur Library collection. And you can see that even though it's the pigment chrome yellow that we're concerned with, what that looks like in terms of the book cloth is actually a whole range of hues. We have sort of more oranges, yellows, some olive greens, some browns. And that's because the chrome yellow is mixed with other colorants. And then along the top row here, you can see a bunch of other bindings that contain chrome yellow. This is called chrome green, and it's created by mixing Prussian blue with chrome yellow, and you can get a whole range of greens. This Life in Danbury in the middle here is very similar in color to emerald green. It's sort of a bright, vibrant, springy green. And then we also found a lot of the deep, rich forest greens were also colored with chrome green. And then along the bottom here are the books which really cause us the greatest amount of concern. And these are the emerald green bindings. So arsenic is the element that is present there. And you can see that they are really a very vivid, punchy sort of green there. So all of these elements, chromium, lead, arsenic, they can all be acutely toxic in high doses. And then they can also cause health problems when lower amounts, when you're exposed in a chronic way to lower amounts of them. But the difference is that arsenic is acutely toxic in much smaller amounts than chromium or lead. So I'm using the descriptive name emerald green, but the compound that I'm talking about is copper acetoarsenite. This is a pigment that was first synthesized around the turn of the 19th century in Bavaria, and it was commercially produced in Schweinfurt, Bavaria from around 1814, and that's why you might see it referred to as Schweinfurt green sometimes. It was also called Paris green, which probably arose because it was used in the sewers of Paris as a rat poison. It's also been known by other names such as Vienna green or King's green, but all of these names are talking about the same compound, and that is copper acetoarsenite. I'm going to call it emerald green during this talk because that is what the chemists who first synthesized it called it. Now, there are other arsenic-based green pigments which were also popular throughout the late 18th and 19th century. You may have heard the term Sheila's green, and that's copper arsenite. So that's sort of the other big popular arsenic-based pigment. And we have not found any Sheila's green in book cloth specifically. It's a more yellowish green, and it tends not to be light fast. Emerald green is, in fact, light fast. And so that may be part of why in the 19th century, you know, once this pigment was discovered and started to be produced, it really kicked off a Victorian craze for bright greens in all manner of household and domestic products. So you can see here on the left, this is a cartoon from a 19th century publication, and it's referring to Sheila's green, but we can take the same message for emerald green. You know, both of these pigments contained arsenic and were dangerous. And so the consumers that were buying the products that were colored with this pigment were really, there was an awareness in the public mind that arsenic is not good for you, but it was something that was really overlooked. There was sort of some cognitive dissonance going on there. Consumers were buying dresses, hats, shoes, children's toys, wallpaper, house paint, interior wall paint, all colored with emerald green and really, you know, reveling in that beautiful bright green. But they were also buying Paris green and using it as a rat poison or as an insecticide in their gardens and on their crops. So it was known that this pigment was dangerous, but that did not seem to impact its use through most of the 19th century. There were actually quite a number of newspaper accounts at the time about accidental poisonings from wallpaper, wall paint, children's toys, and things like that. There is only one mention in the literature that we've found so far of accidental poisoning by book. And you can see over here on the right, this is a photograph of a book owned by the private collector Ronald Smeltzer, who shared this image with me. This is an early French paper binding, so it's from 1816, I believe, and it's a paper colored with emerald green. And I'm pairing it here with this report of a poisoning by book cover, because this is what I imagine the book cover in question would have looked like. A little boy in New York was using a book as a watercolor palette. And so you can imagine him sharpening his brush by putting the brush in his mouth and then swirling it, swirling his watercolors on this emerald green containing book cover. And of course, in that way, transferring arsenic into his mouth. He did recover, he did not die, but he had a few days of agony in the meantime. So actually, I do want to mention that we have some colleagues who are looking specifically into emerald green bookbinding papers and have found that they were very popular in continental publications and especially in the 1830s and 1840s, but this paper was used throughout the 19th century. So the XRF analysis that we conducted at Winterthur could tell us that arsenic was present, but it couldn't tell us how much arsenic was present. And so for that, we had to do what's called destructive testing. We had to actually cut a sample of book cloth from under the paste down on one of our books And we sent that off to the University of Delaware's soil testing lab, where they have a protocol that they could use to digest the material and give us a hard number for how much arsenic was present in those 3 square centimeters of book cloth. We also conducted what's called offset testing or pickup testing, where we swiped the book cloth with a dry cotton pad and also a dry cotton swab. And the intention of that is to sort of was to simulate what might offset onto your hands when handling these books. And so we also had the cotton pad and the cotton swab tested at the soil lab. And the results were really quite astonishing. The results showed that this book cloth contains far more arsenic than any of us had anticipated. Basically, an average-sized octavo book contains roughly 1,000 times more arsenic than the OSHA exposure limit for inorganic arsenic. And what was offsetting on the cotton pad and the cotton swab was 2 to 5 times more arsenic than that safe exposure limit. So this is the point at which we realized that we really needed to continue down this path of research, that we weren't just being alarmist, and that actually quite a lot of arsenic is present in these bindings. So once we understood that there was a significant risk, we started reaching out to other health and safety professionals, as consultants, to help us wrap our heads around how we can interact with these books, store them, handle them, use them safely. And the first step was to move all of our books out of the circulating collection into the controlled environment of our rare book vault. We definitely did not want patrons to be able to check these books out and take them home. As adults, we know not to put books in our mouth, right? But children and pets, for example, often behave unpredictably around items. And one of the things that they often do is stick things in their mouth that they shouldn't. And so it is really important to keep Emerald books away from children and pets. So, a point that I'd really like to make is, we know not to lick books. And that is the best way to keep yourself safe. Don't lick an emerald green book, or really any book. But the risk that emerald green books present is much greater than just the risk of death. Chronic exposure to inorganic arsenic can generate a whole host of other health problems. And so it is really important to be diligent in the way that we handle these materials and really, take the health and safety recommendations seriously. Chronic exposure to inorganic arsenic can cause skin lesions, it can cause peripheral neuropathy, and it has also been linked to a host of cardiovascular, respiratory, and liver disorders. And it's also been linked to several types of organ cancers as well. So the routes of exposure are many. You can actually absorb a small amount of inorganic arsenic through the skin. But the most dangerous routes of exposure are inhalation and ingestion. So when handling an emerald green binding, it's important to wear nitrile gloves or latex gloves. I usually say nitrile because so many people have latex allergies. And honestly, I think the N95 masks that we've all been wearing in the time of COVID are also a great idea. Again, just to reduce the risk of inadvertently inhaling any pigment dust. While handling these books, of course, you want to avoid eating, drinking, smoking, nail biting, touching your face, anything that could bring the offset of the book onto your hands or gloves into an area where it can then be taken into the body. Even if you've worn gloves, it's a great idea to wash your hands afterwards. And you should avoid using these books on any kind of soft upholstered surface. So don't read them sitting in an armchair or on a couch. You know, rest them on a hard table that can be wiped down with a damp cloth afterwards, just to make sure that any shed pigment dust has been removed. For storage, this is something that my colleagues and I have sort of gone over and over, like, is there any better way of storing these books than sealing them in a zip top polyethylene bag? It doesn't look great, and I'm the first to admit that. But honestly, we really believe that this is the best way to store these books. The plastic, protects, you can pick these up and the plastic is going to provide protection from anything offsetting onto your hands. And that zip top seal is going to keep any pigment dust that might shed off of these bindings contained. They're also great because you can see the book through the plastic without having to open up the baggie to handle it. And at least in the case here at Winterthur, we don't store any other books in a plastic bag like this. And so it's a good immediate visual cue to someone that there's something different about this binding. We're also tucking little warning labels into each baggie as well. So we individually label our bags, and then we actually store them all together in the rare book vault on one shelf. And that shelf is also labeled. So this is a photograph of the binding for Rustic Adornments for Homes of Taste. This was the second edition, which was published in 1857 by Shirley Hibbard, and John Layton, a rather famous English illustrator, did the book cover design. And this is the first book that we discovered that contained emerald green. Once we found the arsenic, I halted conservation treatment of it. Ordinarily, I would have lifted the cloth along the edges here, inserted new cloth underneath to rebuild the case. But once I really understood how much arsenic we were dealing with and how readily that arsenic could offset or shift, the introduction of moisture in the form of adhesive could cause more arsenic to migrate to the surface. And so what I ended up doing with this binding is actually encapsulating it in Mylar on all four sides, and creating this sort of wrapper that can wrap around the book, which I put into a brand new arsenic-free binding. And we found this to be a good compromise because it means that actually the book can still be handled by researchers and read and used. And then we just store it with its original binding. So you may be wondering at this point, how will I know if I am looking at an emerald green book? Well, we have found some commonalities, and I've got little asterisks here next to American or British imprint and the publication date range. And that is because our data collection is ongoing. And so these are sort of our initial guidelines, but they are subject to change as our data set grows. We have mostly been looking at American and British bindings, but we do know that emerald green book binding papers were popular in Germany and France, and it is also possible that there may be cloth bindings containing emerald green from other countries as well. We have found that most of these imprints are from the 1840s or through the 1860s, but so far, I am finding through my historical research that I think this book cloth was mostly produced in the 1850s. I think the handful of books we've found from the 1840s may have been remaindered books that were bound later. And it's possible that the imprints from the 1860s were sort of using up old stores of emerald green book cloth that might have been lying around. But most of the bindings that have been identified have been from the 1850s. And to date, based on research that we did in Winterthur and at the Library Company of Philadelphia, and based on data contributions from many colleagues and about a half a dozen other institutions so far, we found about 88 bindings that contain emerald green in the book cloth or in other areas of the binding. So you can see here sort of the range. The one in the middle here is perhaps most modestly decorated. It is blind stamped, although it's hard to see in this image. And then some of them are really quite luxurious, like the Crystal Palace, which is the one on the far left, is a 3-volume set with gilt edges, heavily decorated, heavily stamped in gold. The book cloth on the boards of all of these bindings tends to remain quite vivid, but on the spines, we do see some color variation. And this image over on the right shows that variation of the spines. And we think that this is because while emerald green is light fast, it is actually very sensitive to sulfurous air pollution. And if you think about the 19th century, London, also American cities, and how much coal was used, how much sulfurous soot would have been in the air, it makes sense that the exposed spines of books on a shelf would be exposed to air pollution and would have that, that color shift. So part of our outreach efforts have involved creating this color swatch bookmark. It shows book spines on one side, book boards on the other side. And it also lists some of the other identifying features of these bindings. So we've intended this bookmark as an outreach tool to raise awareness about emerald green book cloth, but also, you know, we were trying to create something that could be a little bit diagnostic. You know, a visual identification is of course subjective and therefore unreliable, but the hue of this vivid green book cloth is consistent enough that we felt like the bookmarks were worthwhile. We mailed out around 900 bookmarks all over the world at this point. To most of the US states and as far afield as Australia, New Zealand, South Africa, and all across Europe, and to some locations in the Caribbean as well. We are actually getting ready to do a second printing of bookmarks. Our first run, we printed 1,000 bookmarks, and we've almost come to the end of our supply. So we're doing a second printing that is also going to include the color range for the emerald green bookbinding papers, which we found do differ in hue from the book cloth. They tend to be a sort of mintier, paler sort of green. And so some colleagues of ours from another institution that's doing this research has generously contributed those images for us. Oops, sorry about that. So two of the Bookmark users were at the Philadelphia Athenaeum. Jill Lemin Lee and Denise Fox received one of our bookmarks. And I believe this was their Halloween week activity. They went through the collection to see if they could identify any likely suspects. And I do know that they began looking in the 1850s and sort of working out from there, as we do recommend on the bookmark. And they identified 5 likely suspects, which they brought to Winterthur so that we could confirm their findings with XRF analysis. And here you can see my research partner, Rosie Grayburn, our graduate student, Kaylee Ferguson, and Jill and Denise looking at the XRF results. And we were able to confirm that 4 of the 5 books that they brought to us do contain emerald green, and they are pictured here. And the 5th book, which did not contain emerald green, we were able to confirm is chrome green. So slightly toxic, but far less so than the emerald green bindings. And these bindings have been added to our Arsenical Books database. So on the Winterthur Wiki, if you're interested in reading more about this project, we actually update the wiki quite frequently as new research comes to light and as new emerald green bindings are detected. And this is where we list the bibliographic information for all the books that have been positively identified so far. It's important to remember that at this time, even though books were being mass produced in the 19th century, as I mentioned before, it was still sort of a partially hand binding situation. And so you could have the same imprint with the same bibliographic information as a book on our list, but it might be bound in an entirely different kind of binding or a different color of book cloth. But even so, we feel like it's a pretty good starting point for people to start considering their own collections. Then earlier this year, Rosie and I founded the Biotoxicology Working Group, which is an international cohort of conservators, scientists, book historians, librarians, and health and safety professionals. We've got about 35 members from all over the world who are interested in this question of identifying toxic components of historical book bindings. And so our goal is to develop reliable methods for identifying these toxic elements, and also developing best practices for the management of these types of collections. So stay tuned to more research coming from BibTox, as we fondly call it. So if you're interested in more information about the project, or if you think you might have emerald green bindings in your own collection, you are welcome to reach out to me directly. You can also reach out to reference@winterthur.org if you are interested in receiving a bookmark. Please put emerald green bookmark in the subject line of that email. And then here's also the link to our wiki project page, which, as I mentioned, is frequently updated. And I'll also note that as we're coming to the end of our first printing of bookmarks, there may be a pause as we're waiting for our next batch to be printed. But if you're interested in receiving a bookmark, I will keep you posted on that. So thank you.
Thank you. Thank you so much. This is fascinating. I've been trying to keep up as I'm paying attention to your talk with all of the comments. We have so many comments in the chat that I'm going to be focusing on the Q&A. So if you have a question, please put it in the Q&A. We have about 24 questions up there now, so I'm going to look through. You may have already answered some of these questions as I was trying to keep track of everything, Melissa. So first question came from Paige, wondering if the terms emerald green and Scheele's green are interchangeable.
Great question. And no, technically they are not interchangeable. So emerald green is copper acetoarsenite, and Scheele's green is copper arsenite. So they both contain copper and arsenic, but in slightly different proportions.
Great. So we have a couple of questions related to the XRF. One anonymous is wondering if you built your own reference library for the samples, or if you used a previous collection to identify the elements. And
That's a great
the other
question.
one, if you can hold two, I'll see if you already had the portable XRF, or if you purchased it, and if you've used it for other uses, or if you have other ideas of how you would use it.
Yeah, great. So I am very, very fortunate that I work at Winterthur, which has a wonderful scientific research and analysis lab, which is headed by Dr. Rosie Grayburn. And so we have a number of wonderful analytical devices there, including the handheld XRF. We also have another type of XRF that can map where the elements are on an object. And we have a bunch of other analytical equipment too. And so our analysis lab supports research at Winterthur. And so they use XRF to look at a wide range of cultural heritage materials, not just books in our collection. And so when we initially started this project, we did use previously existing reference samples for emerald green that already existed for the XRF spectra.
And I think someone here is curious about brand and model and how much a reader costs. And I'm wondering if there's someone maybe you might refer them to, or someplace you could refer someone to who's interested in learning more about purchasing an XRF.
Sure. We use the Bruker handheld. I would say it sort of depends what you're interested in doing with it. I know that some of the devices are intended for geological surveys, and so they produce data in parts per million. And if you're interested in using XRF for cultural heritage applications, then I really recommend that you get the kind of XRF that produces a spectra. You know, I mentioned that sort of spectra. And the reason for that is because that type of device allows you to see the raw data. The devices for geological applications that spit out parts per million, you don't ever have access to the raw data. Within the device, it processes the raw data, runs it through a bunch of algorithms, and it spits out data that's already been processed. So it's actually much easier to get accurate readings and to manipulate that data in different ways if you get the kind of XRF that produces the spectra.
This is funny. So many people are talking about Umberto Eco's book, The Name of the Rose, and then the movie,
yes.
which of course is what I always think of also. So
yeah.
I think that could be great, a great little use clips from that for if you're teaching this in a conservation preservation class. Kay is wondering if board books for infants have been checked for poisons.
Oh, well, what a great question, Kay. You know, as I mentioned, this pigment was really used in the 19th century. So I assume you're talking about children's books from the 19th century. And I will say that one of the books that we identified as containing emerald green is called Grandpapa's Tales About Animals. And it was a children's book. You know, intended for Victorian children so they could learn about exotic animals, which is rather terrifying. But I mean, this emerald green paint was also being used on children's toys at this time period. So
yeah, Perina and Alander in Sweden says that there are cases in Sweden of children who licked the fruit on the wallpaper and died.
Oh, heartbreaking.
So it's things that we do for beauty, right? Elspeth from University of Nevada, Reno is also undertaking a binding survey, and she is curious if when they're in those zip top bags, if they can safely remain shelved with the rest of the collection, or if they still need to be separated.
We have been shelving ours. I mean, I mentioned that they're all on one shelf together, but I do think that the plastic provides enough of a barrier that they can be, you know, if you want to keep them in order. I would just say, you know, something to think about. One of the reasons that we pulled ours out, first of all, at Winterthur Library, we're already set up to be able to do that because we separate our folios and our miniatures according to size. And we put a little letter code at the end of our call number to indicate that. So it was pretty easy for us to just do that for our poison books as well. We only have 10 books in our collection that have emerald green. But we also thought it was a good idea to store them together, thinking ahead to a disaster scenario. If we're ever in a situation where there's a water event or a mold outbreak, or, you know, God forbid, a fire, all those books are contained and together. And we're actually adding a special safe handling guideline to our collection emergency plan as well, just so any salvagers or first responders are aware of the additional risk there.
So we've received a lot of questions about humidity, mold, moisture for books that have been put in plastic bags, and if there's any concern.
That is certainly a concern if your books are stored in an area that does not have good climate control. I have no concerns about storing the books in plastic bags in a climate controlled area. And even though that zip top is tight enough to hold in pigment dust, it's not so tight that it's not allowing air exchange. There is still air exchange happening. You know, I think you're probably faced with a difficult decision if you're storing books in an environment that is prone to mold. You know, you sort of have to ask yourself, what is the greater risk? You know, how do I want to store these? Maybe you could have, you know, the top of the bag not sealed to allow for more air exchange. And as long as it was upright, it would still be containing the dust. I should mention that if these books get moldy, then there's sort of another layer of risk associated with them, because there is a type of mold that digests copper acetoarsenite and releases arsenic gas, which is the most toxic form of arsenic. And in fact, that, you know, all the newspaper accounts about people getting sick from their wallpaper, they weren't necessarily licking the wallpaper, as those poor children in Sweden did. But in the damp English climate, you know, mold and mildew was growing on the wallpaper and it was releasing this arsenic gas. And so when people were spending hours in their dining rooms, they were breathing it in, and that's what was making them ill.
So we have, maybe we have painters upstairs. We have some alarm going off right now. So that's why Tess has disappeared. But until they come and knock on my door and tell me I have to leave, I'm assuming it's all good here. Lots of excitement. You have construction people, we have stuff. Rivka and a few others have wondered if you've changed your cataloging practice to reflect the status of the binding.
Well, as I mentioned, we have the code for our call number, and then we do also put a note in the catalog record about it, as well as physically labeling the physical item as well. And, you know, we haven't served any of these materials to patrons since the start of the project. I think in part that is because of the pandemic and the shutdown, which sort of coincided. This project got underway in 2019. So, but you know, something that we are trying to work out with our legal counsel is whether we need to require users to sign some sort of waiver saying that they've been informed of the health risks associated with looking at one of these bindings. And then, you know, our library staff are all trained in how to handle these bindings safely, but we would then need to have library staff instructing users as well. We're definitely recommending that if a patron is really most interested in the content of a book, then we would direct them to either another copy of the book or a digitized version of the book, rather than having to handle the emerald green binding.
There's so many questions here. I'm trying to go through and see the ones that are just for everybody who's questions. The recording will be made available. Absolutely. There's a lot of questions about that. A lot of questions here about potential cross-contaminations with other books that were next to them.
Yes, that offset came off so easily on cotton pads and swabs. Yes, that the arsenic will offset onto neighbors on the shelf. Absolutely. We have some colleagues at another institution who, and I I just want to say I'm not mentioning the name of the institution, not because I don't want to give them credit, but because they are not allowed to talk about this research publicly yet, under orders from their PR team. So these colleagues at another institution did do some testing on adjacent books to emerald green books in their collection, and they were able to find a detectable amount of offset. So that is something to think about. If you find an emerald green book on your shelf, you may also want to do a swipe down, maybe just with a dry cotton pad of its neighbors on the shelf, and then discard that cotton pad, if you're able to, through some kind of safe hazardous material disposal. We have hazardous material disposal through the University of Delaware. I know that's not something that every institution has. If you find you have a large collection of these bindings, that may be something that you want to investigate what your options are there.
I don't think we'll do one more question. We've just had to evacuate from the building, but we still have internet connection as I'm standing out here in the cold on the steps.
I hope everything is okay.
I do too. I will find out soon. But one final question is, has research been coming along on other colors?
Yes. So right now we've been focusing on chrome yellow because that is the next most toxic compound of concern, high in lead and chromium. And then next on our list is mercury, because we did find one red binding that contains mercury. So we are expecting that maybe vermilion is present. But we will continue to move forward, and we will continue to update the wiki with that information. I should mention we've also just recently published a peer-reviewed article on this topic in the Journal of the American Institute for Conservation.
Thank you, everybody. I know people are saying, run away, be safe. I think we have most of our staff out of the building. I'll find out what happened, but we're so glad that you all came, and this recording will be made available for everybody. Melissa, this was a fantastic presentation. We had people from, I think it was 44 states and territories and about 25 different countries coming in for this program. Thank you for joining us. Many thanks to Melissa and to everybody for joining us for this program. We look forward to seeing you all virtually or in person at future programs. Have a wonderful day, evening, good night, wherever you are at in the world. Thank you so much.
Thank you, Beth. Be safe.
Thank you. Bye-bye.